let's take a look at Getting Ready 3.4. So, first type of problems is where we're just graphing the pair of points, drawing a line that goes through both points, and trying to write an equation of that line. So, the way we're thinking about this is this would be our y-axis, that would be our x-axis. They don't print off very well, so there we go. So 5, 2, we'd go to 5 for the x, 1, 2, 3, 4, 5, up 2, so right about there. Then 7, 0, go 1 out to 7, and 0. Okay. Now, what we're thinking about here is slope-intercept form is going to be the easiest way to figure this out. So we've got to find the slope and the y-intercept. Slope goes here, y-intercept here. Well, it's pretty easy to find the slope based off our points, right? We know that from this left to the right, because we always go left to right, we go down 2 and to the right 2. Okay, so as a fraction, down 2 would be a negative 2, to the right 2 would just be 2. Negative 2 over 2, we can simplify that to be a negative 1. So I've got y equals negative 1x. Then we can just use that same idea and go backwards to our next points. Okay? Either 2 or 1. So we just keep jumping back till we get to that y-intercept, which would be up at 1, 2, 3, 4, 5, 6, 7. So a positive 7. Draw your line, and there we go. So let's try it with number 2. So we've got negative 4 up 2 right there, 6, and then up 7. Okay? Now I could go ahead and just try to draw my points there, but it might be easier to kind of label it first. So how do we go from this point up to this point where, well, we go up 1, 2, 3, 4, 5, and then we go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we went up 5, so it's positive, over 10. We can simplify that to 1/2. So we've got y equals 1/2 x, and then we've got to figure out what our y-intercept is. So, being that we simplified this, we'll be able to find some of those points in between. So I go up 1 to the right 2, up 1 to the right 2, and I can keep going, and you'll see that we match up. So, there we go, there's our graph, and then we go up 1, 2, 3, 4, so it's a positive 4 for our y-intercept. And there we go. So that's all we got to do. Okay, now let's take a look at these ones. These ones are a little bit more difficult. We're still going to graph them, but we got to look for the recursive and explicit. Okay, so what we're dealing with here is a sequence. Now, on some of these it might be a good idea to make a table of values. Okay, and when you're dealing with just a sequence, the x would be like the term number. So 2 here would be the first term. Okay. Then we'd have the second term, which would be 4. The third term would be 6. The fourth term would be 8, and we could just keep going on if we wanted to. And so this is the sequence number. So when you're graphing it, the term number would be like our x. So we go, 1, 2, 3, 4, 5, 6, 7, 8. You could keep going. Okay, this would be like the sequence number. So 1, 2, 3, 4, 5, 6, 7, 8. So make sure you're labeling these. You may even want to put some of these numbers down to give us an idea that we're counting by ones. So we just graph the points. So 1, 2, 2, 4, 3, 6, 4, 8. You should be able to see a pattern going on here. Okay, so kind of like what we did last time, we can figure out an equation based off these points. Okay, so for your explicit, that helps it out. So basically what you need to do is go back to the 0 term, okay, to figure out what's happening. Well, how are we growing here? We're adding 2 each time, right? So if we were going backwards, we'd subtract 2, and we'd end up at 0, 0. So our point y-intercept would be here at 0. Okay, so if we're doing explicit slope-intercept form, right, where the x is 0, the number you have for y, that's going to be your y-intercept. The slope is, this is like the y, the x, the growth in the x under the growth in the y. The growth in the y, we're adding 2 each time. Growth in the x, we're adding 1 each time. Well, what's positive 2 over positive 1? Just a positive 2. So that's my slope. So my explicit equation is y equals 2x plus 0. Or you could just write, okay, had a little bit of a technical difficulty there. I accidentally opened up another program. So you could just erase and just write 2x. Either one works. Okay, either one of those works. Now the recursive, remember, the recursive is something like the next term equals the previous term, and then whatever we did to it. We added it by 2 here. But I don't want you writing it like that. I want you to get into the habit of writing the next term as f of n standing for these numbers here, equals the previous term, which we'll call f of n minus 1, because say, n was 3, what would be the previous term? It would be 2, which is 3 minus 1, plus 2. So write it, f of n equals f of n minus 1 plus 2. And it's pretty much that same format that we're going to be following. The other thing you have to do with recursive when you're writing it like that is tell us, well, where did we start? Well, what was our first term? It was 2. So that's another aspect you have to remember. Okay? Let's try number 8. So it says, Claire has $300 in an account. She decides she is going to take out $25 each month. So, a good idea is kind of use another table of values. So, we could call this, months and money. Or you could call it n and f of n, or x and y, or any of those. Okay, so when we start out, before we start taking any out, we have 300. Well, after that first month, how much did we take out? Well, we took out $25, right? So we'd have $275. After the second month, we took out the same amount, so it'd be $250. After the third month, $225. After the fourth month, $200. After the fifth month, $175, and so on. 6th month, 7th month, 8th month, keeps going down by 25 each time. And we could keep going. So, if we're going to graph this, we could call this our months, or you could call it n, or even x. And we go, 1, 2, 3, 4, 5, 6, 7, 8. Now, we'd call this side the money, or y, or f of n. Okay, now what are we going to count by here? Well, we need to start up here at 300. We go down by 25 number increments, so it might be good to start out like that. Count this one as 25, then 50, then 75, 100, 125, okay, 150, 175, 200. And I'm going to run out of space here probably, or have to go a little higher. So that was 200, 225, 250, 275, 300. We'll call that 300. Okay, so we start out at 0, we're at 300. Then at 1, we go here. 2, we go down, and we keep going down. Because we're counting by 25s, we basically go down one at a time. And there's, we can keep doing our dots, but we don't have to. Now, don't get fooled into thinking our slope is just down one to the right one. Because we're not going down one, right? We're going down 25 each time. Whereas here, we're going up 1 each time. So, slope-intercept form. Our slope is the y over the x. Well, we're going down negative 25 for the y, going up 1 for the x. We'll simplify. Negative 25 divided by positive 1 is just a negative 25. That's our slope. Now our y-intercept is where we start. We start when our months are 0, which is 300. So 300 is our y-intercept. So explicit, y equals negative 25x plus 300. So you can see for the explicit, if you have a table, it's pretty easy when you're dealing with this, linear type of function to do this. Now recursive, well, what is our first term? It's 300. Okay, so we've got that. Then for each term, what are we doing to it? We're taking the previous one and subtracting 25. And there we go with those ones. Okay, hopefully you're seeing some patterns here and getting some ideas. Now let's take a look at 12 and I think 14 together. Okay, so now we're dealing with geometric. What you have to remember about geometric is we're not adding or subtracting, we're multiplying and dividing would be another way of saying it. Okay, so let's take a look. Now we're given a table already, so it should be pretty easy to graph, right? So we've got time here and number of cells here. Okay, so 1, 2, 3, 4. Now we've got 3, 6, 12, 24. So we're getting up to 24, so we may want to number it a little differently. The easiest would probably just be count by threes. 3, 6, 12. Oh, count by threes, that would be 9. Let's try that again. So we've got 3, 6, 9, 12, 15, 18, 21, 24. So we start out at 1, 3, 2, 6, 3, clear up to 12 now, and 4 is clear up to 24. So being that this is geometric, it means it's going to be an exponential equation. Remember, those ones aren't linear, they're a curve. They look like this or this. So you can kind of see the curving going on here for our graph. Okay, now, the kind of similar to the slope-intercept form we've got here is this equation, where A is your y-intercept and B is that growth. Okay, so basically, how are we growing on this part of our table? Well, how do we get from 3 to 6? How do we get from 6 to 12? 12 to 24. What are we doing? We're doubling it. So we're timesing it by 2 each time. So our growth is we're timesing by 2. Okay, because this is going up by 1. So that tells us what our growth is. Now, where's our y-intercept? Well, go backwards. How would we get to day 0 up here? Well, what number times 2 is equal to 3? So if you're going backwards, think division. What's 3 divided by 2? Well, it's 1.5. So our y-intercept would be at 1.5. Be right about there, halfway there. Okay, so that's about how we draw our graph. So then you just put those in place and get y equals 1.5 times 2 to the x. That's our explicit graph. Now our recursive, how do we do that one? Well, the same way we've been doing it. What are we taking? We're taking, to get our next term, it's our previous term, and what are we doing to it? We're doubling it. We're timesing it by 2. But remember, we want to keep it in this notation. So same notation, f of n, for our next term. Our previous is n minus 1, and what did we do to it? We timesed it by 2. Then, where did we start? Well, our first term was 3. And there we go. Okay, little trickier, same concept, but just a little trickier, because you have to know this exponential one. Okay, where that's our y-intercept, that's the growth. Okay, now let's look at this one. Tanya creates a chain letter and sends it to 4 friends. Each day, each friend is then instructed to send it to 4 friends, and so forth. So how would we write a table of values here? Okay, we'll call this n and f of n, or x and y if you really want to. So, who started it out? Well, Tanya did. Okay, before she sent it out, she was the only one. She sends it out to 4 friends. Okay, so after the first day, 4 friends have it. If we were to draw a picture of it, she sends it out to 4 friends, and each of those 4 friends send it out to 4 more friends. Okay, so basically what are we doing each time? We are multiplying by 4. So day 2 we've got 16. Day 3 we've got 64. And so on. Day 4 it would go even higher. What is that? 256. Okay, so here we would have our days, and here number of people contacted. So at day 0 we only had 1, right? But the problem with this is we've got to get clear up to 256. This is easy. 1, 2, 3, 4. Okay, but up here we've got to get a lot higher. So maybe we could call this 250, and half of that would be 125. So about half of that would be right there. So how would you want to count? That's the tough part here, because you don't want to go too slow, but you can't go too fast either. So I'd probably try counting by, honestly, I'd probably count by 25s. 25, 50, 75, 100, 125, 150, 175, 200, 225, 250. Okay, so let's graph this. So at 0 we're at 1, so we're clear down here. At 1 we're only up to 4, so we're not much higher. 2 we're at 16. Okay, so even less. I know my graph doesn't look that good, but you try to do as best you can. At 3 we finally jump up to 64, so that's a little above 50. And then at 4 we're all up past 256. So this gives you a good idea of how quickly these kind of grow, just like that zombie project. So there we go. Now our recursive. Well, where did we start out on day 1? We started at 4. What are we doing? We're taking, to get the next term, we're taking the previous term and we are timesing it by 4. Okay, so what's our growth? Well, this is going up by 1, so our growth is timesing by 4. That goes right here in the B part. Where did we start? Where's our y-intercept? It's at 1, so it's f of n equals 1 times 4 to the n. You may have written it y equals 1 times 4 to the x, same thing. Okay, you may even write it as f of n equals 4 to the n. You may just said timesing by 1 doesn't do anything, so we leave it there. Either one of those works. Okay, so a little more difficult, but we're still doing the same exact process. Follows that same idea. Okay, let's take a look at one more. This time we're given dots. Okay, so at day 1 we had 6, so make a table. So we've got days here, and we've got dots. So n and f of n. So day 1 we had 6. Day 2 we had 12. Day 3 we had 24. Okay, so pretty easy to tell. What are we doing? We're doubling it each time. So if we were going backwards to before, how many did we begin with? Well, what's half of 6? It's 3. So we began with 3. So 1, 2, 3, 4. And we'll go one more. 48. And maybe count by 5s, 5, 10, 15, 20, 25, 30, 35, 40. 45. So at 0 we're at 3, so about right here. 1 we're at 6. 2 we're at 12. 3 we're at 24. So right about there. And at 4 we're clear up here to 48. So it looks like it curves kind of like that. Okay? So 1, 2, 3, 4. So now let's take a look at our equation. So our y-intercept is this one, so it's 3. Our growth is this one, so it's times by 2 to the x. Now, if we wanted to do the n and f of n, we'd go f of n, that's like the y. The result is 3 times 2 to whatever day we're talking about. Our recursive, well, what's our first day? Well, it's 6. And to get our next term, we take the previous term and we times it by 2. And there we go, guys. So hopefully that helped you out a little bit, and you kind of connecting these dots, so to say.